look what is the recurrence relation is. So recurrence relation is nothing but it is a sequence of terms like a0, an, a1 like this, and it is an equation that relates an to certain of its predecessor, these values. So I can write it like a n equal a of n minus 1 plus uh, some constant value, or so we can write some constant value here. So this is a recursive definition or recursive equation or formula. Okay, means this function, let's suppose it is a function or method. So this function is called on smaller inputs of n, and this is some kind of constant values or the cost incurred in that particular function. And what is this, I will tell you shortly in the some later slides. Okay, so we can define it like this. Suppose we are having a function t of n, then I can write it like t of n by 2 plus some constant value or some value depends on the input n. Okay, so this is a recursive equation. This is a recursive equation. So there will be some initial conditions for the sequence. Initial condition means like let's suppose we are having a recursive equation for Fibonacci series. So for the Fibonacci series, they are the base condition. Initial conditions are the base condition. Like if this is the function and this is the recursive equation for the function. So as this n which reduces like this n minus 1, then when this will be expanded, then there will be some value in the form of a of n minus 2. So this will be reduced, and it will be reduced till the base case. Base case or that case of which we know the value for that particular base case. Like suppose the base case is a of 1, and we know the value of a of 1 some constant, or the base case is not a of 1, it is a of 0, and we know the value of that particular a of 0. Okay, so in this type of recurrence relation, there is a base case, and we know the value of that particular base case. So the base case is not dependent on the input n. Okay, means we simply reduce the problem into by using some kind of formula, and at the end, when the problem is decomposed into an undivisible form, that is the base case, and we know what is the value of that. Okay, so let's take an example here. This is the recurrence relation here. T of n equal, it is a constant value if n equal 1, and it is the recurrent or recursive case for n greater than 1. For n equal 1, it is some kind of value here in the form of constant. Abhi kya hai, I will explain you shortly. And for n greater than 1, the value of this function will be this 2tn by 2 plus bn plus c. So when this problem will be decomposed into a problem of size 1, at that time the value of the function will become a. So the portion of the definition that does not contain t is called the base case. So this is the base case, which is not dependent on the input n. And the portion that contains t is called the recurrent or recursive case. This is the recurrent or recursive case. It is dependent on the value of n. Okay, so the recurrence relations are useful for expressing the running times, that is the number of basic operations executed of the recursive algorithm. So today we will discuss about how to do the formation of recursive equations if we are given a function or method, and if we are given a recursive equation, then what are the different methods to solve that particular equation. So this is an example of a Fibonacci sequence. So Fibonacci sequences can be defined in the form of recurrence like this: f of n equal f of n minus 1 plus f of n minus 2. And it is the case when n greater than equal 3. So we can write it like this if we are denoting it in the form of a function like t of n equal. The value will be 1 for n equal 1 comma 2, and it is t of n minus 1 plus t of n minus 2 for n greater than equal 3. So this is the recursive function for this Fibonacci sequence. So these are the base case or the initial condition. So when this particular problem is decomposed into a problem size of 1 or 2, in that case the value of that particular problem is 1, and that will be fetched whenever we want to solve that particular equation. So basically this is the Fibonacci series. Okay, now just we will do some formation of the recurrence relation. I will show you by two examples. Let's suppose we are given this function and we want to find out the recursive sequence for this particular function. The function name is f, where we are just passing an integer value, and if the value of n greater than 0, then this will happen, this will execute. And this is for n greater than 0, means this for n greater than 0 and it is dependent on this n, means until the value of n is greater than 0, it is dependent on itself. It will be called on the smaller values of n. Okay, so this will be the recurrence. Now what is the base case? Means for n greater than 0 this value, so it means for n equals 0 there will be some value. So the base case is reached when n equals 0 in this particular function. So the method performs one comparison. If the value of n equals 0, then this will be the one comparison, means n greater than 0, the condition will be false when n equals 0. So the method in this case perform one comparison. Thus the number of operation when n equals 0, t0 is some constant a. There will be a single comparison operation, so we are assuming it like a, or we can say 1. And for the rest of the cases, when n greater than 0, the method performs two basic operations and then calls itself using one recursive call. So this is the recursive call, this is the one basic operation, this is the second basic operation. So we can denote them by a constant b, and this is the recursive function. So we can simply write it like, if we are writing it in the form of a recurrence relation, like t of n is equal when n equal 1, we can write it 1 or a constant value. Suppose we are writing at a constant value like a, and it will be two operations, so we are denoting them some constant b, plus it is t of n minus 1. So the recurrence, the function is called self or for the value of n minus 1. It will be for n, no, it is not 1, it is n equals 0, and it will be for n greater than 0, like this. So when n greater than 0, the method perform two basic operations, then call itself using one recursive call with the parameter n minus 1. So this can be the recursive function, recurrence relation for this particular function. Now let's take one another example so that it will be clear to all. Let's suppose we are having this another recurrence, this function, recursive function. Now if we want to formulate the recurrence relation for this, then you can see here the function name is g, where we are passing a parameter n, and if the value of n equal 1, then it will return 2, otherwise it will return this. So when we focus on this one, then you can see it is independent of the n. It is not depend, this value doesn't depend on the n, and it is dependent on the n basically. So the base case, this will be the base case. So base case is reached when n equal 1 in this case, and the method performs one comparison and one return statement. So we can denote this by a constant c, one operation this, one operation this. And in the else part, you can see here the function is calling itself 2 times for the input parameter n by 2, one time here, one time here, and this is some kind of constant value for some basic operation. So when n greater than 1, the method performs 2 recursive calls, each with the parameter n by 2 and some constant number of basic operations. So we can, if we want to write the recurrence relation for this, then it will be C for n equal 1, and it will be, you can see here, suppose it is constant b plus tn by 2 plus tn by 2, means 2 of t n by 2 for n greater than 1. So this will be the recurrence relation of this particular recursive function. Okay, so
here n can be greater than 1, or it can be any value other than 1 also.
no, only for greater than 1, not for all values, because this will be the base case. Okay, I can explain you. Let's suppose the functions is this. Okay, and the recurrence relation is, you can take the case of the binary search, and the binary search case was t of n by 2 plus some kind of constant value here. So you can see here, initially the size of the problem is n, then it is reduced to n by 2, then it will be reduced to n by 4, then it will be reduced to n by 8. So this problem will be reduced by half until it will be in the stage that it will become a undivisible problem, means a problem with one element. If it is a binary search, and in the worst case it will reduce to a one element list. In that case, if it may be possible that the number we are searching for will be that element, or the number is not present in the list. So you can see here, we are going downward from n to the base case. Okay, so after this base case there will be no recurrence relation. So these all recurrence relations are for n greater than 1, and this for n equal 1, there is some kind of constant value which is independent of n, and these all values are dependent of n. Is it clear?
Yes, sir.
So these are some simple methods. Here we are just viewing the function and just forming the recurrence relation. Now let's suppose we are given the recurrence relation, then what are the methods to solve that recurrence relation and to find out the complexity of that particular recurrence relation? Because it is very easy for an iterative equation. If we are given an iterative equation, means like we are given a sequential program, then we can just calculate the cost of each and every statement and finally do the summation operation, and we can find out what is the complexity of that. But if there is some kind of recurrence or recursion in a function or a program or an algorithm, then we don't know that how, after how much time that particular code will be executed for number of what are the number of steps for that. So for doing or solving such type of recursive functions or recursive equations, we are having here 4 methods. The first one is the substitution method, second one is the iteration method, third one is the recursion tree method, and fourth one is the master method, and it is also known as master method or master theorem. So this is the substitution method. In the substitution method, it is based on the mathematical induction. So in this method, we simply guess the solution of the given recurrence relation, and by using the mathematical induction, we simply prove that this solution is for that particular recurrence relation. जो question में given था. It is the iteration method. So in this particular method, we simply expand the recurrence for some other values of n, and simply form a series or sequence of operation, and by using some by viewing that particular series, we simply find out the time complexity. Third one is the recursion tree method. So in the recursion tree method, we solve the recurrence relation in the form of a tree like this, and we simply find out after that, expanding it in the form of tree, we will do the summation of the cost of at each level, and finally do the summation at each level cost, and this will be the time complexity equation. So in the substitution method, we don't know what is the solution, so we simply guess the solution and prove that by mathematical induction. And there may be some cases where we are unable to guess the solution, then this recursion tree method will be used to for guessing the solution for substitution method. Okay, we guess from here and prove by the substitution method. And last one is the master theorem or the master method. So in this master theorem or master method, we are given three cases, and these three cases or the three formulas are based on are computed based on the growth of the function. Like we are having two functions now in the asymptotic notation. First one is the fn, second one is the gn, and we simply measure the growth, and accordingly we simply identify three formulas. So whenever there is a question given on the recurrence relation, so we just check like which case uh, is applying on that particular recurrence relation, and after identifying that, we simply use the formula of that given case and find out the solution. So these are three methods. We will study each and every method separately in detail, and we'll solve some questions on that.